In this video, we're going to go over the WASCOB tool, which will be citing water and sediment control basins. WASCOBs are more than just a funny word. They're small embankments built across small drainage ways in agricultural fields, and they have a lot of potential. They can reduce sediment and total phosphorus loads, they have decreased peak runoff discharge, and can lessen gully formation. The NRCS recommends installment on watersheds from 2 to 50 acres in size. Alright, so let's go ahead and set our tool up. We'll go over to our impoundment siting toolset and open up the second tool called WASCOB. You can see we have 8 inputs. We have the field boundary feature class, the unfilled DEM, or new DEM, the flow accumulation roster and the flow direction roster, our stream reach, our watershed boundary. We need to specify an embankment height for the WASCOB in meters, and then our Z factor. So let's go ahead and add these in there. I'm going to grab my field boundaries, drag and drop. You can see many were automatically populated. We need to still add our new DEM. A default of 1.5 meters has been provided for the embankment height, which I'm going to keep, but you can feel free to change this. It just must be within the range of 1 meter and 4.5 meters. And then we have the Z factor, 0.01 for me. And we see we will get one output, and that is our WASCOBs, which is going to be a polygon. So everything looks good to me. I'm going to hit OK. We'll let it go. So here's a brief explanation of how the tool works. Flow paths that drain at least 2 to 50 acres are found, and then points are created every 200 feet along those flow paths, and these must be within agricultural fields. Pasture is included in this case, so the ISAG value can be equal to 1 or 2. We then test to make sure that there won't be flooding happening. So if the elevation change between one point and the next upstream point is not enough and that upstream point would be flooded out, the point is removed. On the points that are still remaining, a 100-meter wide transect line is drawn perpendicular to the mean direction of the flow of that particular drainage way. In the next step, the elevation profile of each transect line is taken and analyzed to make sure that both of these following criteria are met. First, each side of the drainage way must exceed the elevation of the embankment. In my case, I chose that 1.5 meter embankment height, so it must be higher than that, and this is to ensure the curvature to necessitate a WASCOB. Secondly, each side of the drainage way must not exceed twice the elevation of that embankment height. And this is just to make sure that the WASCOB is not too incised. So in our first example here, the first one fails because one side of the bank is over twice the height of the embankment, while the other side is still below the height of the embankment, so this fails on both banks. And then the second one is a success. Our left bank is 2.3 meters and our right bank is 2.1, so it's over that 1.5 meter embankment height that I specified. However, it is not twice that value. In the last couple steps, any WASCOBs that touch each other or are within 10 meters of each other or intersect a field boundary are removed. And then finally, information on the upstream drainage area to each WASCOB is calculated. So let's go ahead and take a look at our results. You can see it's been automatically added. I'm going to make these stand out a bit more. Let's see. I'll make them yellow. Hit OK. And there's a lot, which isn't too surprising. So let's just zoom into an area and take a look. We can see in our hillshade some of these areas where flow would accumulate along there, so it makes sense that that's where the WASCOBs are being placed. And in general, they're all perpendicular to that downstream direction. Now, if we wanted, we could go into the attribute table and see which ones have more contributing area compared to other ones. If we sort by this, we can see that there's quite a few that are only going to have about 2 acres feeding into them, and then we go into higher values as we go. So this could be a way to prioritize your selection. You may want to build ones that treat more area compared to smaller area. The other fields that we get with this output is a WASCOB ID. We have an elevation associated with it, and then we have the embankment height that I specified. This is in centimeters. We have the left bank height and the right bank height, and both of these are also in centimeters. And then we have the length of the WASCOB that was built here. Of course, this could be changed as far as the actual engineering of the WASCOB. So here's a brief recap on that WASCOB tool. If you would like to develop WASCOB drainage basins, go on to the next video, lecture number 22, where we get to find our WASCOB basins. In this video, we're going to go over the WASCOB basins tool. The WASCOB basins tool finds the potential storage of ponded up water upstream of each WASCOB. This is done by burning the WASCOB's feature into a filled DEM using that embankment height value, and sink regions are then delineated behind them. Before running this tool, erroneous WASCOBs should be either manually deleted prior to running, or only WASCOBs of interest can be selected before running as well. The output of this tool is going to be a polygon, and then optionally a depth raster may also be generated. So let's go ahead and run this tool. I am going to apply selection to my WASCOBs so that the WASCOB basins tool is only ran on certain ones. So to do that, I opened up my attribute table. I click on the menu of options and I'm going to say select by attribute. And I only want to see WASCOBs with a contributing area that's, let's go with greater than 5 acres. So I'll hit apply. Alright, close. And we can see that I'm going to have 319 WASCOBs that are going to have basins generated for them. So now I can go to the WASCOB basins tool in my impoundment siting tool set. It has 4 inputs: the WASCOB's feature class, a filled DEM, the flow direction roster, and then our Z factor, of course. We're going to get our WASCOB basins as an output, and then we have an optional output too, which is a depth raster for each basin. So I'm going to grab my WASCOBs and drag it in there. You can see things were manually added and this was automatically populated. I'll type in my Z factor, and then I am going to also create the WASCOB basin depth raster. I think it's a good visual to have. It may help too with understanding the construction of the WASCOB. So I'll save it to the correct file geodatabase. I'm going to call it WASCOB depth ras. And then, as always, we'll end in our 12-digit HUC ID. So I'll push save. Everything looks good to me, so I hit OK. Alright, so the tool just finished running. If we zoom in, we can see that, yes, they were only generated for the ones that I had selected. So I'm just going to do a little symbolization real quick. Let's see, I'm going to do this by contributing area. 2 classes, classify. Set this at 5. Okay. And then I'm just gonna make that null, so now I'm only gonna see my WASCOBs that the tool was ran for. Hit apply. Okay. And it looks like the other ones disappeared, but really it's just a symbology. So then we can go into our basins attribute table, take a look at the information we got. See, with each one, it has that WASCOB ID associated with it. We get the storage in acre feet for each one, and then the surface area of each basin too. So we can go in and symbolize this, just make it look a bit nicer. Let's see, we can go with blue, since it'll be water. Make it kind of transparent so we can see underneath, get an idea of what's going on. And then what I find to be more valuable output is the WASCOB depth ras that I chose to create. So I can turn that on. I'll go into the symbology and add some color, make it look nice. Got standard deviations that I'm going to do from current display extent, hit apply. Okay, and now we get an idea of the actual structure of that basin, where the deepest point will be, how much of it is going to be shallow, things along that nature. So that's the WASCOB Basin tool. Have fun with it, choose different WASCOBs. I'm also going to mention here, if you have a watershed planner with you or have some knowledge yourself on the engineering of WASCOBs, you can feel free to select these WASCOBs and change the angle that they've been placed at if something makes more sense to you, or just the width of them, and then rerun this basins tool, and the output will vary slightly based on how that WASCOB was burned into your filled DEM. So have fun with it, explore, see the engineering potential behind these tools. Here's a brief recap on the WASCOB Basins tool.